Good day, students. This is Bridget speaking. Today I'm going to just go over some problems and some basic principles regarding Kirchhoff's law. Now, we're working from page 114 from your combined study guide, and I'm just going to break down some problems that some students have requested and just go through some stuff with you guys. So Kirchhoff's laws, basically, there's two laws. There's law 1 and law 2. Law 1 is the Kirchhoff's current law, which basically means that if you have several conductors that meet at a point, the total current towards the point is equal to the total current leaving the point. So if we look at figure 4.17, this shows it much more clear. If we take this point here of a circuit, so this is a piece of a circuit, as this point indicated by the black represents our reference, we see that current 1 is entering, current 2 is entering, and current 3 is exiting. Therefore, we can summarize by saying that current 3 is equal to the sum of current 1 plus current 2. The law 2 further goes on to talk about the voltage drop. So this basically is Kirchhoff's voltage drop law. And in this law, it states that in a closed circuit, so the circuit has to be closed, the algebraic sum of the products of current and resistance for each part of the circuit to the total applied EMFs equals to 0, which basically means that if you take current, which is I, times R, that is actually voltage. So the sum of those products plus the total EMFs will equal to 0. That the examples we're going to do now are going to make things a bit more clear. So 4.18, the figure basically just shows the second law and the product of current and resistance and what it explains and so forth. But let's jump to this image here, 4.19. Again, you remember Kirchhoff's second law states the sum of the voltage drop plus the sum of the EMFs in a closed circuit would equal to 0, which basically means that the sum of the voltage drops will equal to the sum of the EMFs in terms of an equation. So 4.18 doesn't have polarizations. It doesn't have any plus or negatives. It's showing you what signs are these resistors. Okay, we can obviously see that with the cells, which is your 5 volt, 3 and 6 volt, you have this longer solid line and the shorter line. The longer solid line represents positive, the shorter line represents negative. We also see a current 1, current 2, current 3 shown. Current 1 and 2 are facing in an upward direction and current 3 is facing in a downward direction. So once we've understood that, to solve this, we're using Kirchhoff's second law. We have to use what we call loop analysis. Loop analysis simply means that you have to have a complete loop in a closed circuit and apply the principle of the law, which means that the sum of the voltage drops will equal to the sum of the EMFs. So if we take this now, the first step obviously with this one is that we don't know the polarization. Typically in your semester tests, in your exams, and in your assignments, you are going to see examples mostly with the polarization stated. But if this occurs, you should be able to label it. Now, let me show you how you would do it. If we're looking at this power source, we see that this shorter line is negative, the longer line is positive. We see the current is exiting the positive and entering this resistor. Therefore, because it's coming from the positive, going to the resistor, we would denote this area as positive and the top area as negative. The same would apply here. We see a negative, positive. The current is exiting from the positive direction, therefore we would have a positive and a negative. Current 3, however, is exiting, which therefore means here we would have a negative and there at the top we'd have a positive. So if we go to the image shown, figure 20, we now see the polarization clearly indicated, as I've mentioned. Okay, so now we have our polarization. The next step is now to do loop analysis. So as I had said, loop analysis means you have a complete loop and you will analyze the sum of the voltage drop and equate it to the sum of the EMFs. Okay, so now I've written this diagram on a piece of paper so we can work together. So let's look at this diagram. We see that I've denoted all the points on the circuit, as in the previous diagram I've shown you from the study guide, and I've additionally also put in my loops. Now, what is a loop? A loop is obviously something that's a circle, and it indicates direction. As you do this course, you'll realize, number one, you can do this direction either clockwise or anti-clockwise. However, you have to have continuity, which means if you name this loop 1 and you say, well, loop 1 is going in a clockwise direction, in the entire circuit, be there more parallel cells or more other cells, you'd have to indicate it in the same direction that you've chosen for the first one, so that you have continuity and it all is the same. Okay, thereafter I just put in current 1, current 2, current 3. Now if we now start our loop analysis, the only thing I want you guys to remember is that what is Ohm's law? Ohm's law is the product of current and resistance. Just keep that in mind, it's very important. So the first loop that we have is the one that exists between A, B, E, and F. So that's loop 1. So if I write down here, we have loop A, B, E, and F, and it ends up again at A. So if we do the loop analysis of this now, we'll start by saying, well, if I'm going from point A, do I see a power source between point A and B? No. Between point B and E, I see a power source, which is the 3 volts. So my current is going this way, which means it's going to enter the positive. So I can write it down by saying plus 3 volts, okay? And then you carry on to the side. There's no power source again. There's another power source now here, which is the 5 volts, but we're now entering the negative. So now we're going to say minus 5 volts. Okay. Thereafter, we're now entering the resistors. So this is now, we've done the power sources, now we're doing the resistors. With the resistors, this current is traveling into the positive. So again, you're going to say plus, but now we need the product of current times resistance. Our current in this area here is I1. So you're going to say 8 ohms, right, times I, and the I is 1. Again, we now come back to our diagram. We're entering the negative, exiting to the positive if we're looking at this, but the current is going to be I2. So now we say minus 5, which is the amount of ohms, times I, and it's 2. And this will be equated to 0. So when you eventually summarize all of this, you end up with 8 I1 minus 5 I2, and your voltages, you can obviously sum that up and you can take it to the other side, and you're going to end up with a positive 2 that's going to sit there. So this will now represent the equation 1. Okay, so now we've done the first loop. Now it's time to do the second loop. I do apologize for the shakiness. I'm using my phone. Hopefully I'll do this one with a tripod next time so that it doesn't shake. I sincerely apologize. But let's look at now loop 2. Loop 2 again is going to be the loop from B, C, D, E, ending off again at B, which would look like that. To do the loop analysis between B, C, D, E, B, we will start off by saying current 2 is going to enter this power source from the negative point. So therefore, when you write it down, you say negative 3 volts. Thereafter, we say, what is the next power source that we have? The next power source that we have is the 6 volts, and it enters the 6 volts in the positive. So therefore, you would say plus 6 volts. Thereafter, we now can look at the resistors. And the resistor, the first resistor we have is the 5 ohms, and this current 2 enters it in the positive direction. So we say plus 5, and we say the product of the resistor times the current, and the current is I2. Thereafter that, we go back to the diagram and look at the last resistor, and the last resistor is the 4 ohm resistor, and it enters it in the positive direction. So we say plus 4 times I3, and this would be equated to 0. When we look at this in totality, it should look like this. We now need to summarize this, and therefore we say 5I2 plus 4I3 will equal to, when you add these two up, okay, it should give you minus 3 seated there. Okay, I3 is now, if we look at this as our equation 2, our equation 2 and equation 1 could have been solved simultaneously. However, there's two equations, 3 unknowns, which won't work. So we need to find a derivative for the I3. What we know from our law, which is Kirchhoff's first law, is that the I3 is equal to I1 plus I2. So if we go back to the notes, we can see that from Kirchhoff's first law, we see that I3 is equal to I1 plus I2. Therefore, you can plug that into your equation, and you'll end up with 4I1 plus 9I2 equals to minus 3. And this is after obviously plugging in here I1 plus I2 and just multiplying it out. Okay, so this still remains equation 2. We now have to obviously solve these simultaneously, and I'll go back to the notes for that so that we can see if our answers are correct. We will just verify. Let's go back. Okay. So according to the notes, equation 1 is 8 minus 5I2 plus 2, which is exactly what we have here. Okay. The next thing is the equation 2, and equation 2 says 4I1 plus 9I2, as you can see here, equals minus 3, and that is what we have written here. Now the next thing, which is solving simultaneously, it is assumed that everyone is capable to do that, which basically will say that you're going to solve for the two equations by simultaneously multiplying the equations by 2 and solving simultaneously. So to have common numbers that can be eliminated. So if you say I1 minus I2, in this case it will be 8 minus 8, then you'll be left with minus 5 minus 18, which is obviously going to be minus 23 I2, and this will give you a positive 8. And then you can solve for I2, and thereafter we can use I2 and substitute that into, let's say, equation 1, and solve for I1, and I1 is seen as 0.033 amperes. Thereafter we can use first Kirchhoff's law and simply add our answers and be able to get I3. And that's how you approach pretty much all the problems when it comes to Kirchhoff's first law and applying Kirchhoff's second law and using loop analysis. This is the first video. I'm going to attach another video where I'm going to do 4.22 now, which is the example some students struggled with, and again we'll work through it together. Okay, so log on to the next video and just download it and you'll get the rest of the explanations.